channel, that is AI next generation. So this particular video we are going to cover about the object detection module, that is a YOLO. What do you mean by YOLO and theory behind the YOLO? So this particular video you will be clear about what YOLO it is doing and what the step it is following to detect the object in the image or the in the video. So this particular video we are going to cover about the whole theoretical part of the YOLO. So in the next video we will just go for the practical part. We will do the coding part for the custom data or that already has been trained on 1000 of classes. So we are going to see many type of object detection while after completing of this video. So before jumping to the coding part, you should be clear about what the theory behind the YOLO. Clear? So this is my website ainextgeneration.com. So you can just go to the ainewgeneration.com. So you will find the various type of Python, deep learning, machine learning and various type of blogs. So you can just read from there, this particular website. So I already written about the YOLO. I will just give you the link in the description of the video, so you can just go through about the that is of the YOLO. Clear? So we will start with the first of all YOLO. So that's already has been written by me. So first of all, before starting this blog, so you must have the all the things that's related to the Python, or you must be experienced with the machine learning, you must be experienced with the deep learning. Either one data, you can just say either one deep learning library, either you know about the PyTorch or you must know about the TensorFlow. Clear? So after completion of the ANN and you are just completion of the CNN, then you are just moving to some object detection module, because in this particular YOLO you are going to use the concept of all the CNN and ANN. Clear? So you are going to use various type of what convolution layer you are just approaching. So this thing what I'm just saying, you already have just uploaded in my YouTube channel. You can just go through about the PyTorch whole series. So you will find how to train a module with the CNN, ANN, also that's related to the images. And whenever even you can just find the blocks in this particular website, so you can just must read this all thing that's related to the deep learning or machine learning. So now this video will be more towards the YOLO. So what do you mean by YOLO? YOLO stands for you only look once. So this is the basically the object detection module. So it was before going to the depth about the YOLO, you must know about the theoretical behind the YOLO and why we are going to do this thing YOLO, and what is different between the classification and what you mean different between the localization. So there are many concepts we are going to see, and then after you will be must aware of why we are using the YOLO and theory behind the YOLO. So even someone in the interview, whenever you are just giving the interview, they are not directly asking you that you should just show me your screen and start doing the about the training part of the YOLO, because it must take time. They will just need that if you know the YOLO, you must know the theory behind the YOLO. So this is the video where you can just explain what I'm just saying, how to say to the interviewer and what the step you're just following in the YOLO to for the object detection module. Clear? So first of all, I will give you one clear definition between the what do you mean by classification and what do you mean by localization. So you must see about the classification. Suppose you are just doing one classification problem that's related to the cat and dog. So cat and dog means once you are just classifying that module, you are just developing that particular module that will only classify whether that particular image in that particular image, whether it is a image of a cat or whether it is a image of a dog. But that is only classification terms. You are not going to localize where the cat it is exact in the image. You want to only classify what is in that particular image. And the second thing about the classification is you can have only one either class. You can either you have in that particular image, either you have the cat or you have the dog. So classification means that particular image will classify as a cat and dog or dog. So you can't classify two things, cat and dog both. So for if you have in that particular one image you have multiple object of that, like both cat and both dog. Okay, so you have to go for the object detection module. Okay, so classification means you are just simply classifying the object, what image it contains in that particular image. Okay, and localization basically means you are just localizing the what particular object and the bounding box, you can just say bounding box of where that particular object it is present in the image. This is called the localization. So combination of detection is object detection is basically your classification. You are just classifying what it is inside the image and what position of that particular object it is in the image. Okay, this is called a detection. And object detection basically means that you are just detecting multiple object in the same image, because whenever you are just performing classification problem, either you are just detecting a cat or dog. Okay, but you can just detect multiple object in that particular image. Okay, so you can just see this one, object detection. So here you are just detecting cat, that the bounding box of this particular dog, this is a dog, bounding box of dog, and also you have the bounding box of the cat, there is a two cat. So you are able to detect the multiple object in the image. Okay, so you can go for the object detection module. I hope so you are clear before going to the depth in the YOLO. So you shall must understand about the what do you mean by classification, localization, and object detection. Clear? So first of all, then after that, what I'm just going to say about the theoretical behind the YOLO. What's YOLO stand for, and what the use of the YOLO. So YOLO basically means you only look once. Means your algorithm, whenever you have just developed, someone have just developed the algorithm. So what they are just doing, they are just passing one time the image. At that time only, they are just predicting the bounding box. You are not passing multiple times the same image. Okay, once the image has been passed, it will just give the prediction of that particular bounding box. It is present, or the object it is present inside the image. Okay, so it is like whenever you are doing the forward propagation in the neural network, you're just predicting the object of that. Okay, what object it is there. Clear? So this is the basically a classification problem we are just doing, and then after you are going, you are first of all you are just classifying, and then after you are just detecting what object it is inside that, and what the position of that particular object is that, and how many object it is there in the image. That is basically called an object detection. That already I have just teach you about this. So what the YOLO follow, how many we are just following the step in the YOLO. Clear? So first of all, what you have just go through how the YOLO works. So inside this you will have the bounding box. So what do you mean by bounding box? I was just saying repetition time, the bounding box. So bounding box is basically it determines the position of your particular object, where the object it is. That is the center of that particular bounding box, and width of that image, and height of the image. Okay, so this is the particular coordinate of that particular object. Okay, suppose in this particular frame you are just saying that this particular car it is present inside this. Okay, so what is the in this image the car is present. So what the bounding box of this will be? So basically it will be the height of that the center position of this particular image. That is the bounding, that is it. You have just drawn the square of this, and then after you have some center of x and center of y of this particular bounding box, and you have the height and width of this particular bounding box. Clear? So it basically it is a rectangle, you can just say. So what the bounding box in this particular YOLO takes as a, it will just give you the five things. Okay, the one will be the PC is basically your probability. So what is the probability that particular bounding box contain an object? Okay, so that will give you in the probability form, and then after it will just return bx, by, bh, and bw. Bx, by is basically your center position of that particular bounding box. Okay, and that is the object, and then after bh and bw is basically your height and width of that particular bounding box. Okay, and then after c is basically the what class it is present inside that particular image. Okay, so this was about the bounding box what you are just doing. So this was, I think it's really easy for you, because you have the four parameter you are just passing. That is the best bx, by, bw, and bs. This is the base four parameter you have to pass before going to the particular YOLO, because whenever we will just do the coding part, at that time I will explain you how you are doing the annotation part. Because whenever you are just feeding any data set directly to the model, you can't say, you have to just annotate that particular data set with the help of many application. It is there, label image, label flow, and there are variety of VGG16 label. So variety of things you can just do annotation part. So annotation part means you are just drawing the bounding box of that, what image present, what exact the position of that particular object, and how the object it looks like. Okay, and then after you are saying what classification object it is bounding box contains. So this will, we are going to see this all thing in the practical part, but here you have to just simply understand what the theory behind it is. Okay, so this was about the first of all what it will return. It will return the sixth item you already seen. PC basically it is, PC stand for the probability of that particular object inside this bounding box, and BX, BY is basically the center position of this bounding box, and BS and BW height and width of this particular bounding box, and C is basically your the class, which class, where it contains the car class. So C it will mention somewhere as a car. Okay, so this was about the bounding box. I hope so you are clear with the bounding box. Then we are going to see about the working concept of grid. So how grid works. So before sending any images to the YOLO to the network, to the neural network, or there will have total 106 layer in the YOLO version. We are going to see this all thing in the practical part. So what do you mean by grid? So grid is basically you are just dividing one image into a grids. Okay, suppose you have some images like you can just take example. This is a this is basically, this is the image. Okay, you can have any image size, and you are just dividing this image size as a 3 cross 3 grid. Okay, so it will be 9 equal part, it will divide 1 2 3 4 5 6 7 8 9. Clear? So what do you mean by grid? You are just saying here. So YOLO, first of all, whenever you are just passing to the images to the YOLO, they will just divide into a grid. So by default, the YOLO, they are just taking as 19 cross 19 grid. But here, I'm just explaining you for the example purpose. So this particular image, you are just dividing the grid into a 3 cross 3. That is a 9 total. You are just dividing that particular image into a grid. Now for every this particular grid, you will just apply the object detection module. Okay, that is a YOLO, or an image classification term. So every that particular module, it will go for the first particular grid, and it will say whether the object is present or not. If the object is not present, it will simply return the 0, means probability of that particular object is 0, means that particular bounding box, or you can just say vector, will not count for that. Okay, for the first grid, because if that particular does not contain any object inside there. So whenever you are just keeping the threshold value of also the probability. So as it is in by default, we are just taking as a probability as 0.5, means below 0.5 probability of any object, you are just keeping that part, and above 0.5 probability, you are just taking that part. So whenever you are just taking probability equal to 0, means automatic, you don't need bx, by, bs and bw. That will be the waste, because there is no object present. So there is no object present, there is no bounding box, so that automatic, this grid does not count. Again, it will go for the second grid, and similar it will go for the third grid. Till here also, you don't have any grid, you don't have any object inside this particular grid. Okay, now this fourth grid will go to that particular module. Okay, that what you are just YOLO, they are just using 106 layer. So this particular object contains some information, means some object it is present inside that. So what it will be there. So and then after the fifth also object, you can just say the best example here you are able to see this is the means many percentage of the object it is covered in the fifth grid. So for the fifth grid, this you can just see about yellow color. So what the probability of object it is there, so you are just keeping as a 1, means 100% there is an object inside that image. Clear? And then after you are just giving 0.67, 0.75, 0.29 and 0.53 is basically your coordinate of the image, that is the center position of x and y is 0.67 and 0.75, and then after height and width of that image is 0.39 and 0.53. Clear? And then after, what do you mean by C1, C2, C3? Here I have just taking the three object, means truck, car and cycle. This is the three object you are just classifying for that particular object, or for that particular, you are just building the model where you are able to that particular model will only classify or only detect the in the images object that will be only the truck, car and cycle. Clear? So here will be the three, you have total three class, that's why you have just writing C1, C2, C3, means that number, how many class you will be have, that number of C1, C2, C3 it will goes, means whenever that particular object, here the object contains the car, so what the car position, you are just doing the one hot encoding for that, means the position of car you have mentioned as second position, and the truck as the first position, and cycle as the third position. So second position it will give you 1, and rest it will be 0 0, because this particular in fifth grade contains the car. So that's why you're just saying that's the class label as a 1. Okay, and then after you are just returning the bounding box and the object it is present, yes or no, you are just returning this thing. And again in the sixth object you are just doing the as it is the same, and see, and then after again it will go for the 6 7 8 9. Again this will be the probability of this will be 0, because there is no object present inside the 6 7 8 9. Clear? So I hope so you understand about how the grid cell works, because you are just dividing these images to a grid, so that every grid you will fit to the model, and model will just apply the object detection module, and it will say where the what object it is present and what is the bounding box of that. Clear? This was about the grid, how we are using the grid, and by default the YOLO is using 19 cross 19 grid. Clear? I hope so you understand about the grid, that what we are just using, and everything I have explained in this blog also detail. You can just visit that particular blogs and you can just read about it. Clear? Already I have, and then after what we are going to see about intersection over union. So till now what you have just done, you have just understand about the grid in the YOLO. But whenever suppose your model is able to detect that particular object, but once that particular, it can be have multiple bounding box. Suppose for this particular object it has detected many bounding box, or you can just 100 bounding box had been detected for this particular fifth grade. So how you are going to remove all the 99 bonding box, and you want to keep the one bonding box that is will be the best bonding box? So you can just calculate with the help of intersection over union. So if someone will ask you what loss function you are going to use in this particular YOLO, thus say you are using intersection over union concept, that is a loss function, you are just calculating for that what the the percentage, what is the percentage, you can just say intersection over union has. Okay, so you whenever your probability of that particular, this is the yellow is, say you can just see with the example, yellow is the actual bonding box, you can just say this is the actual bonding box of the car that has been not, this is the actual bonding box, and the what model has been predicted, that is a green bonding box, the model has been predicted. So then after what you are going to see, you are going to see intersection over union. So this part will be the intersection over union, this part will be over only the intersection over union. So what you are just saying, you are just finding the percentage, what the percentage of intersection over union it is. So by default the threshold value we are just keeping as a 0.5, means intersection over union we are keeping as a 0.5, means above 0.5 you are just counting that bonding box is a perfect bonding box, and below 0.5 you are just removing all the bonding box that has the probability as a 0.45. That's the intersection over union, you are just calculating for that. Clear? So here also you are, the one condition is that you are just removing the bonding box that has the less probability, but still you are not removing all the bonding box. Suppose you have 2 to 3 bonding box that has probability greater than 0.45, then for that case you are going to use, that is a non-maximum suppression. But I will go distinct non-maximum suppression after you should understand about the intersection over union. So intersection over union, you are just calculating what intersection over by the union. Okay, so what the actual bonding box is and what the model has been predicted the bonding box, you want to just calculate the overlap between them. Okay, so this is you are able to see, and then after what you are just doing here, you're just calculating some, suppose the you are just taking some, sorry, you're just taking some threshold value for that. Okay, suppose the red one is basically the model has been predicted the bonding box, and green one is the actual. So what you are just saying, it's intersection over union percentage come as 0. You can just say 0.4034. That is really less, means you are just keeping something as a intersection over union more than 0.5, or threshold value you are just keeping as more than 0.5. For that you don't want this particular intersection over union. Then you are again, you are just calculating the second bonding box intersection over union, again it came as 0.7330 something also. Okay, so again it's like 7.3, but still you are just keeping this bonding box, and 0.9 you are just also keeping this bonding box. But the problem arises, you are just doing what intersection over union it is doing, it is just calculating the probability, it is just calculating the intersection by union. So what percent means, what the probability it is returning, or the percentage this is overlapping. So if the higher percentage, like if it is above 50%, you are just taking that particular bonding box, and if it is less than 50%, you are not taking that particular bonding box. So but this works particular now, but the main question arises, whenever you are just for the same object you are just detecting multiple bonding box, still you are able to remove some bonding box, but still it can have above the 0.5 bonding box. How you are just finding the best bonding box among the all? So for that you are going to use the non-maximum suppression for that. Clear? So what do you mean by non-maximum suppression for that? So it's sorry for that. This is the basically the after whenever you have used intersection over union, after that particular step you are going to use the non-max suppression for that. Okay, means you want to just predict one bonding box, you want to keep only one bonding box, and you want to remove all the bonding box present inside that particular image for that particular image. Okay, because only one bonding box will be present for the one image. If it will be like multiple bonding box for the same image, so the model will give you not good accuracy what you are just hope so you are getting. Okay, so this is the I already explained about the, you can just do with the help of non-maximum suppression the base bonding box, it will just give you the base bonding box among the all bonding box. Clear? Okay, so here also you can able to see this is the, suppose you are just getting above 0.5 the 3 bonding box, but which one is the base bonding box, again you are just going with the highest probability of that. Okay, among that highest probability you are just taking this one has the highest probability that covered the face. Clear? So this particular bonding box you are just taking what model has been predicted, so this is the base bonding box, you can just say. So you can just do this all thing with the help of non-maximum suppression. So how it works, you can just see it will describe all the bonding box that has probability less than 0.6, means I have just given with you example also. And then how it works, and this is the base bonding box, you can just say. So it's non-maximum suppression is really help us to improve our accuracy of our model. So whenever you are just going for the loss function in the, means what the loss coming in the YOLO model, you are just directly going for the intersection over union, then after follow with the non-maximum suppression for that. Clear? So here every particular bonding box contains some probability, and on which has the highest probability, then you are just keeping that particular bonding box as the best bonding box predicted by our model. Clear? and then after you are just going for the anchor box. What do you mean by anchor box? See, this all thing I'm just explaining you whenever you are going to do the coding part, or whenever I will just make you the understand about the YOLO architecture, that is a darknet 53, and how it is going follow flow of that. So at that time you will be must aware about the what the anchor box, what the bonding box, what is intersection over union, what is done maximum suppression. So you are clear with this, and this is really the theoretical part. So you are able to thing you are able to explain whenever even someone will ask you what do you mean by YOLO, and what the various type of things it is present inside the YOLO, and what the loss function you are using for the YOLO, and basically what the anchor box in the YOLO. So they are intersection over union, non maximum suppression, they are the random question. Even now it is the interviewer, they are just asking this type of question, and you must know about this theoretical part of that before jumping to the practical part. So what do you mean by anchor box? Anchor box is really useful. Really, you can just say whenever for the same object you are just detecting multiple bonding box, that is a overlapping is happening. Like I can just take the basic example. Suppose in the one frame you are just detecting two things, say for that is the center position of that particular object for the car and for the truck will be the same. At that case you have to use the anchor box, because that particular the bonding box that has been predicted inside the one bonding box, you will have multiple object. So one bonding box contain the multiple object, and they have same center, that is the center of x, and center of y, that is center position of both the image. Then how you are just determining that inside that particular bonding box has which particular object? So you are going for the anchor box. So anchor box is basically the predefined box that already is trained during the training time of the YOLO. Clear? So anchor box, it is basically say that what the shape of is, because you know the anchor box of the shape of this particular card, and this you can just say the whenever you are just drawing the bonding box, the shape of the anchor box of the car will be the different the shape of anchor box of the truck. So whenever the truck and car that have same object, you can just say same image, same object is present inside the bonding box. Okay, so you are unable to detect what object it is present inside the bonding box. So you are going for the particular anchor box, and anchor box you will say you if you have the same center position of both this particular, you can just say about the car and truck, then you're going for the anchor box. And anchor box is a predefined structure, it is written. Okay, predefined bonding box, it is rare. So whenever you are just taking, so it is able to understand about the which particular object is present inside the things, because based on their structure, the you can just say, I can just explain this thing in layman terms, the width and height of the bonding box for the truck will be the more as compared to the car. So bonding box of that is the anchor box of that particular truck will be the different from the car. So that you are using the anchor box concept, and then you are able to see what object it is present inside that bonding box. Clear? So this was about the also about the anchor box, and it's really useful whenever you have the same object inside the one bonding box, and how it can have two images, three images, or you can just say three object present inside the same bonding box, and how you are going to say that inside that bonding box contains all the three different objects. So for that you are going to use the anchor box, and for the every anchor box, every object the anchor box will be the difference, and on the basic of that depends upon the shape, it is able to determine what present inside that anchor box. Okay, so this was about the anchor box, and I hope so you understand about the theoretical behind the YOLO. So YOLO is really useful object detection module whenever you are going to train a object detection, or you want to detect the object present inside the images, that is the multiple object you can just do even for the images and for the videos. So this was about the theory behind the YOLO. I hope so you understand. So the next part we are going to see about the practical things about the YOLO. We will use for the custom data set also, we are going to use for this particular pre-trained model also. Everything we are going to cover inside the YOLO. So that's all for this video. Thank you.